Hi, this is Andrew Bonnell, and today we're going to be looking at inelastic and elastic collisions. One of the things about the applet I want to mention is that there is a lot of data in this applet. In fact, it spits out like 500 rows of data. And so it's going to be a lot of work to keep track of all this data, but spreadsheets keep track of tons of data for us. So let's look at the first case. The first case is the elastic before, and I've already copied in my data, and once again I mentioned about the titles before. If you like this style better, then you can use the style the lab manual says put all the titles here and all the units here. Also remember that if you can put in the first couple numbers of the index and then copy it down and copy it all the way down, or you could drag it down 500 rows. So to find the velocity, we're going to need to do the delta function, and so here I want to remind you what the delta function is in position over time, but it's the delta position over delta time. And so it's 1 after minus 1 before divided by 1 after minus 1 before. And so the same thing for the ball 2. So it's 1 after minus 1 before, 1 after minus 1 before in time. Now I want to show you a little trick. You could copy this value, Control C, and you could paste that in the next column, but now we need to make sure we shift over these two so it collects from that column. Sometimes I do that to save on typing, and sometimes I type it incorrectly. And don't forget that you don't need to worry about these values for the moment. We'll look at them soon. Now for momentum, we need the momentum of ball 1, momentum of ball 2, and the total momentum. Now I use the defaults from the reset, but you need to change some of the parameters. So your graphs are going to look a little bit different than mine. Now the momentum is simply just the velocity times the ball mass, and so it's just plain and simple. Now the velocity or the ball momentum of the second one is once again just the mass of ball 2 times the velocity of ball 2, and the total is just the sum of those. Now the total momentum error, I'm not going to tell you how to find that, but you should remember how to find that from some of the previous labs we've done. And once you have found that, and the next thing you can do is create a chart of all your momentums. To do that, what I'm going to do is I'm going to go ahead and select the time column and the momentum for each ball and the total momentum. I'm going to go to Insert, Scatter Plot, and there's our scatter plot. Now if you notice along the x-axis it goes all the way to 500. That's actually the index number and not the time. To fix it so it's actually the time, what we've got to do is we've got to move this column down 1, because it's using this time name as one of the points of data. And as soon as we move that down, you can see how all those are correct now. Now the next thing we want to do is we want to edit the legend because it's selecting these rows, and it's not going to let us move this whole thing down. So to edit the legend, what we can do is right-click and select Data, and we can move that up, and our first row of data, if we move that out of the way, see the blue dots, ball 1P. We can edit that title, and we could just simply type in ball 1P. Now another way to do it is we can go to Edit, and now we can actually select the cell. So right there I just selected the cell. And the third way is you can just change the cell by changing it. So it used to be $1, now it's going to be $2. And that changed to that as well. Now what we want to do is we want to make the points smaller. And so to do that, we're going to double click on a line and click Paint Can Marker Options, Built In, and make that 3. Now we just select on another one and we do the same thing, Built In, make it small, select it, Built In, and make it small. Now we want to select that middle row, or wherever your total momentum is, and we want to add in Aero Bars. And right before I'm going to add in Aero Bars, I'm going to move this way just a little bit and remind you that you have this total Aero Bar column right there. And so you're going to add Chart Element and Aero Bars, more Aero Bar options. And if you notice, it created these huge vertical Aero Bars, and there's also horizontal Aero Bars on this graph. And we'll fix those in just a second. So instead of the paint can, we're going to click Aero Bar Options. which is those three little bars. Come down to the bottom, and it chose 1, and we want to specify our value. So we click Specify Value. Now instead of 1, what we're going to do is select this column. To do that, I'm going to delete what's in there, select that, select the first value, and then go Shift-N down, and hit Enter. Now I'm going to do the same thing, and since I'm already at the bottom, what I'm going to do is hold my Shift button down this whole time, Shift and up, and keep holding the Shift, and just hit down arrow once. And what that did is it would have selected that value, but now it doesn't include that. And I'm going to hit Enter. And let's see if it fixed my error bars. Even though it was blank for a second, it did fix my vertical error bars. Now it still has horizontal error bars, which we need to delete. And so to delete that, you select out here, not on the data points, and you just hit delete. Now if I was to zoom way into that, let me close that for a second. If I was to zoom way in, you can see very small little error bars attached to that data. Remember, the data points themselves are very small. Don't forget to add in axis titles and make a fancy chart title. To do so, you can click Add Chart Element and go Axis Titles Primary Horizontal. Again, with Primary Vertical. Did I click the wrong one? Primary Vertical. There we go. That one's selected, so I can type in momentum and put in units, kilograms, meters per second. I can do the same thing down here, time in seconds. And then, when writing annotations for this chart, to give you a little bit more space, you can actually change this axis, which it looks like I somehow turned off. There we go. To turn it back on, you can go Add Chart Element, Primary Vertical. And now the axis is turned back on. I can double click it, and I can change under the bars, under Axis Options. I can change this to a bigger number, let's say 1.2, and I have more space above the data to put in annotations. For example, one good annotation could be, this is where the collision starts, and this is where the collision ends. Alright, now let's take a quick analysis of kinetic energy. And so I'm going to scroll up a little bit, and there we go. And now our formula for kinetic energy is 1/2 mv squared. So if I click in here, you see that here's my velocity column, and here's my mass of my ball. I should have maybe dragged it over a little bit and put it in kilograms. And those dollar signs before the G and the 1 mean that it's going to stay fixed on that cell. So if I copied it down, the column, that G1, it's going to keep picking from that one, even though my velocity has changed. Same thing for my second ball. The total, of course, is just the sum of the two. Now, we're going to create a graph like we did before by selecting the columns in the time column, and don't forget to shift the data down just a little bit. And when you do so, you'll have a graph that looks like this. And here, my set of data, because I have the same masses and the same velocities as I just reset the applet, only shows 2 lines. But if you choose different velocities and different masses, you're going to actually show 3 sets of lines here. And if you said that the velocity is the same, or sorry, the kinetic energy is the same before and after, well, you can't really definitively say that without doing further analysis. And so to do that analysis, you're going to need to find a point before the graph. Let's see if I can do that. So right here, I see 0.58, and you're also going to need a point after the graph. So let's see if I click on the graph, and there's 1.59. And so let's go ahead and copy the time column over to another sheet, and I'm going to go ahead and value paste that one in, and go click back over to my data, and click on my total kinetic energy. I'm going to drag that over just a little bit. Control C, and before, paste values. And now, that top row had that bad value because of the formula. So what I'm going to do is I'm going to right-click that and delete, shift cells up. It's very important that you only select those cells and shift them up. If you delete any more cells over there, it's going to ruin some of the formulas. Now I said it was data before 1.59, and so there's my data right there. I'm going to go ahead and shift N down and delete that. And now I'm going to go ahead and copy down my uncertainty a little bit. And now I'm going to go ahead over here, perform regression. And there's my error bars. I can go ahead and fix error bars. My error bars got just a little bit smaller. I can copy my standard deviation of my residuals over to there and paste it down. And you're going to do the same thing with elastic data after. And here's an example of what that looks like. Now there's the error bars. And you're going to state whether that number lines up with the number in this fit box. And if it does, then before and after are the same. Right here, my number said 0.5 with a very small standard error. Elastic error after was 0.06, so my data did not. However, I changed the data in this worksheet, and if I copied it over, it should line up. Finally, you're going to repeat the experiment with an inelastic case, and so you'll copy that sheet over, and here's an inelastic case. And then you'll paste in your data. It'll be right there, and all your formulas should automatically recalculate. If you chose different masses for your balls, you're going to change those. And you're going to create graphs. Well, your graphs are already created for you. They'll even have error bars on them. And so this is the case where the two balls have the same velocity and the same mass, and they bounce and stick together, and then they kind of reverberate. If you notice, the momentum changes wildly, but then the total momentum is really fixed. And here, we actually lose kinetic energy. That's it for today. Thanks for watching.